Go, starting recording.
Yeah, it hasn't popped up here yet.
Oh, I've got a red light on mine.
Ah, there we go.
Awesome, there we go.
Right. Well, hi everybody, and welcome to another of the other user group talks. My name's Rory. I run the user group together with Shahid, and in the background we've got Dan and we've got Will from Microsoft who are helping out. Basically, we are recording this, so if you don't want to be recorded or anything, please just drop off now. In terms of questions for Paul, we'll do the questions at the end. So at the end, if you do have questions, please just raise your hand and Paul will go through the list one by one. We've also reached out to some of the other user groups across New Zealand. So we've got people from the Azure user groups in Hamilton, Wellington, Christchurch and Dunedin. So welcome to all of you. And it's definitely something that we want to be continuing with because now that we do have a kind of a virtual and hopefully hybrid in the future, and we can be far more collegial and far more interactive and just get everyone involved. So basically we have Paul Smithdale. He's going to be talking to us about GitHub Advanced Security. So Paul, would you like to introduce yourself, and then the stage is yours.
Great, thanks Rory. Yes, as mentioned, see if I can control my slides. I can. Paul Smithdale. I'm a technology strategist at Insight. I've worked across a few different technology stacks in my time, including start off in in BI and all the old analysis services products and Power Pivot. Done some IoT, web, Kubernetes. Right now, really focused on enabling our teams to be productive and deliver business value. So we've got a strong focus on GitHub because it underpins everything that we deliver. And that's me. I look after the APAC region for Insight as well. So it's really great to be here in New Zealand and in person, although virtually for everybody on here. And then jumping into what we'll cover today, a few bullet point lists here, but we'll probably jump over these sections quite quickly. I just want to give a brief introduction to GitHub. I'm sure everybody on the call is well versed in GitHub and what it does, but there's been some great developments on the platform recently. So we want to go over what GitHub offers currently, and then we'll go into and a little bit of history about the journey for GitHub and Microsoft and where we're going from here. And then we'll get into why we do code security and how GitHub aims to solve some of those issues. Not everything, still some responsibility on developers and real-time analysis, but definitely that ship left motion and what we can do while we're in the software development lifecycle. And then we'll jump into some Q&A at the end. So going straight into it, what is GitHub? I think everybody understands GitHub as a Git repository tool, managing your pull requests, collaborating with your team, but they've put a lot of work recently into building out some fantastic features. CodeSpace has been released recently, which if you haven't had a go of it, it's incredible just to jump into a containerized environment, have all of your tools configured, and if you've got teams, people coming into your team and leaving your team, reducing that startup time for them, the barrier of entry to contributing to your team is really awesome. And it's also, if you're working in lockdown corporate environments, being able to have all those tools available and access to NPM and public package repositories. It's been one of the coolest things I've seen come out of GitHub recently. GitHub Actions for your workflows, GitHub packages. I mentioned NuGet, NPM, Maven can all be hosted through GitHub packages. GitHub Advanced Security that we're talking about today, and GitHub Issues, which is going on through a real transformational process, and the new projects are still in beta, and we're starting to see new bits and pieces come out all the time. In the numbers, so some of these numbers change every time I see a GitHub deck come out. I'm pretty sure next time I'm posting a photo of my smashed Avo breakfast, it's probably going to be via pull requests the way these numbers are going. But one of the big ones here is the Fortune 100 number. So we tend to think of GitHub as a place for open source collaboration, but this number 84% shows that it's been taken seriously as a place for enterprises, and we're definitely seeing a lot of customers start to make migration journeys from existing platforms and leveraging great features in GitHub. So to understand where we are today, I put this slide together to take a little trip back in history. So in terms of products and platforms, what are we looking at? It's 14 years ago that we had GitHub being founded, February 2008. So short period of time to stack on a lot of features and all of those numbers. And then in the Microsoft realm, 2013, we had Visual Studio Online land. So that was a real big shift from the traditional team foundation services on-prem to a cloud presence that really helped us work with cloud environments. And then from there, Microsoft had a bit of an identity crisis. We went from Visual Studio Online to Visual Studio Team Services to Azure DevOps. And I think, Microsoft said, it's way too hard picking a name. Let's just pick GitHub. So October 18, Microsoft acquired GitHub. And then from there, we saw some of the synergies of these two companies coming together. First of all, we had pipelines announced by Azure, and then the first link between the two platforms is we got to associate Azure boards with the GitHub commits, so you could see those changes in your repository show up on your product backlog. And then from there, these 4 large dots, we can see the rapid development of the GitHub platform. So when you think about the Microsoft development team for Azure DevOps, they're a part of the GitHub team now. So the collaboration of minds has started pumping out some features. So you saw GitHub Actions released, which I believe a lot of our contents are forked from Azure pipelines. Then GitHub Codespaces, which we mentioned at the top, GitHub Advanced Security, and we've got GitHub Issues, which is still in beta, but we're continually seeing some great features released from there. The aim for that is to provide some parity with Azure DevOps. So I'm sure they've got a lot to do, but it's a high focus area, so they want to get it right. So now we're going to come back to the future and what it means for people adopting Azure DevOps and also GitHub. So Microsoft's vision is that they're going to bring the capabilities of both these platforms under a single product, and that's going to be GitHub. So if you're going to get the most for your teams and be in the right place to adopt new features as they come out from Microsoft and GitHub, you really want to be on GitHub. Now, that's not to say that Azure DevOps is going away anywhere. It's staying put. Even within Microsoft, there's heavy use of Azure DevOps. So you can continue using that platform, but then you want to start thinking about how can we move across. And as I mentioned in that history, there's great integration between Azure DevOps and GitHub. So you can use both platforms right now. Advice is maybe have your code in GitHub so you can start using some of the new features like advanced security, continue to use your boards and test plans in Azure DevOps. And then as the new features come out, slowly migrate across is the path of least resistance. If you're not an Azure DevOps user, what we're seeing is the target state for companies that have multi-platform environments. They might have GitLab, they might be using Jira, there might be builds from Jenkins, is that you can start consolidating all those products and licenses across from your existing platforms and get some great benefit with GitHub. And then if you're new to cloud, use GitHub. It's fantastic. Why not? So now we're going to get into the topic for today, and we're going to start asking the question, why code security? I like to think of the world as a great big API. And the way we access a lot of these APIs is via an API key. Some platforms are really good and they let us authenticate using some form of federated identity and OIDC. But the realism of it is that, you know, most of the time you're going to be given an API key, and as we're developing, we're going to be testing against these services. We might have those API keys in our code, and mistakes happen. And we're seeing, or GitHub's seeing this trend of more keys being committed into code. And that's a real issue because it's exposing your software to security breaches, elevation of privilege, which then leads to data breaches. So we need to do something about this. The other issue that we're seeing is, you know, we've all heard the term that every company is a software company. Puts incredible strain on trying to hire the right people and enable our teams. And we're also building very complex applications for our organizations. And as those applications become more complex, we have a lot more junior staff. We start to see more vulnerabilities slip into our code. And when we are so stretched, it's hard to be across that. Despite best efforts to have pull requests and reviews, things are going to get through. So again, problems that we need to deal with security and vulnerabilities in these large code bases that we have. So what does that mean? We need to put some kind of security checks into our software. A lot of the time I see organizations do pen testing. They might be advanced enough to do real-time analysis, but this is happening at the very end of the software development lifecycle. We're talking about pre-prod, and sometimes organizations are doing it in prod. We get the release, and then that's the main focus, and we'll hire a company to come in and do our pen testing. So that's all fantastic. We're doing some due diligence there, but what happens if we find an issue? So we'll see this, you know, deploy the production stage there, and a dollar value of 7,600. So it's an indicative number, but the reality of it is, if we find an issue, we've got some result from the pen test that says that we've got a vulnerability that we need to fix. We need to re-enable our development team. They've got to context switch from any new development they were doing, and they have to put their context into what they were doing when they develop the feature that needs to be remediated. Now, if that is a change that needs a modification or remediation to your infrastructure, you can see that $7,600 price tag is going to go up, because now you've got to do some redesign, redevelop, redeploy. What you're incurring here is the cost of a new development and new issues in your backlog. And then at the extreme case, look, maybe the pen testing didn't find it, or it didn't happen in the first place. And the first time we know about this vulnerability is somebody has actually breached our system. And we're talking about either the cost of data loss or the cost of reputation, when we have to explain to our shareholders that we have lost data. So what we want to do is shift everything left. We want to realize these vulnerabilities, or stop the vulnerabilities from happening as soon in the development lifecycle as possible, because we can remediate it without all of these additional costs or loss of reputation. And the way that GitHub is addressing this is via advanced security. Go across some the features that comprise advanced security. We'll go over these in detail. I'm going to flick through these quite quickly. So first of all, dependency review, where it's impossible for us to build our current software platforms without help from the open source community. So we are pulling things from NPM, from NuGet, but we've got to have some faith in the packages that we're pulling. So having a dependency review automates some of the responsibility and onus, removes it from our developers. I mentioned as well in this presentation so far, we're going to be dealing with APIs. Might be a security principal in Azure, and we need a client secret. Secret scanning, its job is to look out for those secrets coming into our code base and potentially preventing it getting there in the first place. Code scanning, when I discussed the complexity of our code increasing, code scanning is provide an automated way of detecting vulnerabilities in our code so that we can remediate it. We don't often always have the time to do a thorough PR and go through everything, so that's going to help us out in that review stage. And then security overview is giving us that single pane of glass view of our security concerns within GitHub. So it's less about the team, it's more about the organization. So we've got these 4 features, but it's not available everywhere. There's a few different licensing tiers for GitHub. If you've got a GitHub handle, you'll have your own GitHub account, and you can create your own public repositories. So that's that first column here. And if you're on a GitHub Teams account as well, you might have some public repositories. Now, GitHub's aware that your breach of identity and secrets is an issue. So you do get secret scanning in there. You do get code scanning and dependency review, but the security overview feature is not there. And some of the secret scanning feature isn't there as well, such as custom patterns. If you've got a private repository and you're on a Teams plan or it's your own account, none of those features are available. And then really, if you're in an organization and you want to leverage the advanced security features, you want to be on GitHub Enterprise Server or GitHub Enterprise Cloud, and then have the advanced security features turned on and the licensing for your organization and get access to everything there. Let's start digging into these features, and we'll start with Dependabot. So I'm sure most people on the call have used NPM at some point and pulled down some packages. What Dependabot's going to do is it's going to help you make sure those packages are up to date. Any Angular developers out there, I'm sure you've gone through 20, 30, 40 updates of Angular. It can be difficult to keep up to date. Sometimes we rely on semantic versioning to do our minor updates, but outside of that, it's going to recognize that there's a new version available for you, and it's going to create the pull request to the change to your packages.json. Same thing if you're a .NET developer and you've got NuGet, it will detect and do those updates for you. Then the next part is security updates. So not all open source packages are safe to use, or sometimes they change ownership and vulnerabilities creep into these packages. There's databases of vulnerabilities in open source packages that GitHub leverages to provide security updates for your GitHub repos. So this is about getting a notification when something needs to be rolled to a different version or rolled up to a safe version. And the notifications for those will happen outside of normal dependency updates. So it's available. I'm not going to go through this list, but there's quite a few package management platforms that's supported by Dependabot. And the last bullet point there is that you've got some control over how Dependabot can be used, and that's done through a Dependabot YAML file within your repo. Lots of me talking. I think it's time to get our hands dirty a bit. So what I'm going to do is come across to a repository I've got, Regress Security, and we'll start to have a look at some of these features. The first thing I'm going to do is jump into my settings section and where we go to configure advanced security for your repository. Actually, I might just call out, is this all visible, too big, too small?
It's great. It's great.
Excellent. All right, I'll crack on. So this top section here is around configuring your Dependabot updates and alerts. So we've got 3 options here: dependency graph, dependency alerts. The graph's going to give you the functionality to dive into what packages you're using and also what dependent packages are within those packages. The alerts will give you notifications of security vulnerability with your packages. Sorry, this one. And the Dependabot security updates. So that this will let you do the pull request as well. I'm just going to scroll down a little bit more and we'll see the rest of the advanced security features. So code scanning, that's going to be your CodeQL, which I'll talk about a bit later. and in your secret scanning, which will detect keys from AWS, HashiCorp, Azure. Now, this is all well and good. We're inside a repository and we're configuring advanced security, but if you're part of a large organization where you might have 100+ repositories, this is going to get really tedious. So I'm going to go across to my organization, and same thing, we'll pop into settings. Thankfully, they've put it in the same spot, code security analysis, and we've got these features here at an organization level. So we can enable the features for all of our current organizations, and you'll notice these checkboxes here. We can also tell GitHub to enable the features for new repositories. Now, it's important to realize the licensing structure for advanced security. It's based on the number of committers in your repository, not based on the number of users within your organization. So if you've got something like a repository that manages your wiki and it's changing constantly, I hope you're not pushing secrets to your wiki, but it's probably not a repository that you need to have covered by advanced security, because it's probably going to kick up your licensing costs. So yep, that's the organization view, and we'll go back to our repository. So next part along, we'll go to insights, and this gives us general health of our repository, but the one that we want to look at here is in dependency graph. And I'll just go through these tabs quickly. So this is your dependency graph here, and you can see my application uses, it's got the ASP.NET Web Stack because it's a Blazor application. I've also pulled in the Microsoft Graph API, which is going to help me talk to Microsoft Graph. And I've got SQL client here, so I'm going to be talking to a SQL database using that package. And we can start diving into these as well. And we can drill down, and somewhere down here, we're probably going to see the JSON package. Here we go, Newtonsoft, everybody loves it. So you get some visibility of what packages are being used by the dependency that you've pulled in. If your publishing packages are consumed by projects within your organization or publicly, you'll see those packages listed here. Sorry, the consumers of your packages here. And then the last one is Dependabot. So it said 23 hours ago, it's checked my my CS proj file, and we can dive into that as well. And those same dependencies that we saw in the dependency graph, we can see in my project file. If you have multiple projects, so within your repo, so let's say we've got an API and we've also got a front end, you'll see different sources here. So my Angular one, I might have a packages.json here as well. So across into our security tab, you'll see our alerts. For this demo, no alerts here. Pretty difficult to go find packages with vulnerabilities. I think NuGet and NPM do a really great job of removing packages that do have vulnerabilities. But if anything was deemed to be vulnerable, this is where you'd see that. Now, I mentioned in the deck, we've got some control over Dependabot and how it acts. Now you need to have this file within your repository to have control. This is your dependabot.yaml. And you can see here, I'm looking, my package ecosystem is NuGet. If you had other package systems that are within your repo, you'd have, this is an array here, so we'll have another entry. I want to grab everything from the root. We can control schedules here, main branch, and then if it does find a package that needs to be updated, I want the review to be me, Mr. Smitty. So there's one, I'm not going to show it execute because it's running at 8 AM Perth time, so we're not going to get that to fire today. But I did deliberately install the Graph API into my Blazor application, and I deliberately set it at version 4. So Dependabot's executed. it's found out that there's a new version that I can adopt. And in the files changed, we can see that it's bumped up the number to 4.29. So if I'm happy with that, I've reviewed the code change. I've come in here, this all looks good. I can accept that. I can do a squash merge and it's going to update. It's going to update that package for me. It's going to run all of my CI. And eventually we'll go deploy that one back out to our operating environment. So through test, pre-prod, prod, whatever you're using. And that's our Dependabot demo. So it's pretty easy to use. Security is best when it is easy. You can get using that straight away. Now, I've got these slides here, tales from the trenches. I've worked on a few projects in my past, and one of the projects I was working on, we had an Angular front end for it. Now, back in 2018, there was a vulnerability called for a project called FlatMap Stream, and I believe that was a project that was being maintained by a guy in New Zealand. Now, he transferred ownership of that package to somebody else, and they added some code which tried to locate Bitcoin wallets within your customers, your consumers' desktop computers within their browsers. Now, we're working on that project, and one morning my devs come to me, all of our builds are broken. For the front end, we had to go look at our dependency graphs from NPM, find out what happened. So NPM yanked that project or made it unavailable. Now, we didn't have a dependency directly on FlatMap, but we were using packages that had a dependency on it. So all of those broke. So for us, we rolled to safe versions. We waited for those packages to update to a different package, and then we were able to adopt them. Now, if we had GitHub Dependabot, we probably would have saved a day, half a day of looking around trying to find out what had gone wrong, and we would have got notifications in the morning that said, this is what's happened. And it would have made life easier for us. So next one along is secret scanning. So I've covered this a little bit in the preamble to this slide, but essentially there's two types of scanning that's available. The first one is partner scanning. So again, GitHub wants to do the right thing by the community, and this will run on all public repositories. GitHub's partnered with quite a few vendors to get the patterns for their secrets and be able to detect them. Based on the platform, there's different operations that can happen. You'll either get a notification of the vulnerability, but with some platforms, it can actually cancel the key for you. With my testing with Azure, it doesn't cancel it for me. I can see that being a big issue if it did. So if you did leak a key accidentally into your repo and it got cancelled, it may mean that your production systems all stop working because that key is no longer valid. So you have to manage that part your side and configure it accordingly. But when you do get those vulnerabilities, you do need to act quick. And then there's the secret scanning for advanced security. So this is going to be enabled for your private repositories. Same partners are available, but then you get some additional functionality there. You can create custom patterns. So if you know it's a base 64 encoded string and you've got an equal sign and you know it's a certain length, you can create a custom pattern to detect those strings if they ever get into your code. I know some API keys have a prefix on that might indicate what platform it's used for as well. So if you know that, be good to get ahead of your developers and get those patterns into your organization. And again, let's jump into demo land. So I'm going to go back to my browser. I'm going to try find my mouse. There we go. So for this one, I'm actually going to go to my cloud platform. I'm going to go to Azure, and I've got this application that I've created ahead of time, and I'm going to generate a new secret. Now, luckily, I've got no permissions configured for this, so I think I'm pretty safe sharing this key as it gets generated. And I'm going to go into VS Code if I can find it. So we'll pop down the bottom. Let's try to collapse everything. Pop down to my app settings now. Hypothetical scenario, I'm a developer and I want to test my application. I'm going to be making some graph API calls. So I'm going to have a client ID and a client secret, and I just grabbed my client secret. I'm going to pop it in here for testing. But yeah, I'm busy. I'm doing a lot of things. But maybe we don't have the right change management in our process. I'm going to add this value and accidentally check it in. And we'll call this, whoops. Commit that, we'll sync it, and we'll see what GitHub does. So I'm in a branch right now, so I'm a little bit protected, but really I'm hoping somebody catches this for me. So I'll pop back here. All right. Now, if I'm reviewing this, now I would have got an email for this as well, but let's not open up my horribly bloated inbox. Let's just go to secret scan alerts. We can see that GitHub has found this secret straight away. It's identified it as an Azure Active Directory application secret. And this is the naughty value that I've pushed into the repository. Now, we might think this is fantastic. It's done a great job for us. It's found the secret, and now we can act on it. We can remove that from this branch, or maybe we delete that branch. But the problem for me is it got into source control in the first place. In some sense, it's already been exposed. So I don't want that to happen. I want it to be prevented at the developer's machine rather than exposed within our GitHub organization. So what I'm going to do is I'm going to come to our settings section. I'm going to go back down to code and security analysis, and there's a new feature. Actually, I need to double check if this is still in beta, if it's been released yet. But we've got this thing called push protection, and it blocks commits that can contain secrets. So what that means is when I hit that sync or my git push, it shouldn't have let that secret get into GitHub in the first place. And the next thing I'm going to do is let's go back to Azure and try something different. Let's go to my function app. Oops. Feel free to copy my keys. This thing does nothing. And I'm going to get the host key for my function app. I go back to my solution. I am not a security conscious developer. My team hates me. I'm going to go put that key into my app settings file again because I want to call my function app. Now, the thing about this key is it doesn't get picked up by GitHub Advanced Security. So what I have to do is I'm going to go to my cheat notes. And I've got a pattern here that represents what I think is a function app key. And go back to GitHub. So here I'm going to create a new pattern. And a sensible name. And I need a test string as well. So I'll get the key that I just retrieved. We've got a match. So it's going to run that across my code. This repository, it's completed, and now I can publish my pattern. So I've got a new pattern for function app host key within my repository. If I try to push that to my repo, I'm hoping it gets prevented. Now, just something else to note here. We're doing this within the repository for this demo. Now, it would be pretty painful if you had to do that for every repository. So there's the same functionality back at the organization level. So you can set it at the org, share it across all of your repos. So I'm not sure if I've paid homage to the demo gods this morning. It might work. I'm hoping it works. It's got to be one demo error. So I've got that staged. That's committed. All right, that's committed. I'm just going to change my output here to Git. And we'll try to sync those changes. All right, we failed, which means I succeeded. So we can see down the bottom here, remote rejected. That's my branch name. It's trying to push to my remote of the same name. Push declined due to a detected secret. So that's fantastic. That's a far better result. Instead of exposing that secret to the organization, I've kept it at the developer machine. They've been notified about it. They can remove it. We've done it with our custom pattern. The same thing's going to happen with your AWS secrets, your Azure secrets, any of those secrets that are managed by your cloud provider. So that's a far better result, and I'm hoping that's GA right now because that is super useful. All right, and from the trenches, so that demo there with the function app key is a real world scenario. I was part of a team doing a stride analysis, which is an acronym for, I'm always going to miss one of these. So spoofing, tampering, repudiation, I keep forgetting denial of service and elevation of privilege. It's a pattern developed for Microsoft for doing security reviews on applications. So we did this, we looked at all the systems involved and how they communicated. We go, well, you're talking from a front end to a back end function app, how are we authenticating? And we had a look at the Angular code and we found a host key in the Angular code. Now, we weren't too thrilled about that. But we want to help our clients. We don't want to berate them. We want to show them the right way to go about it. And there was a few different patterns that we could have used to resolve this. We could have enabled easy auth for the app plan hosting the function apps. For this client, we recommended putting API management in front of there because they also wanted to do some header inspection and various other governance elements with their APIs, and they had lots of function apps as well. So it gave us a central product that they could consume by their front end. So with GitHub Advanced Security enabled for that client, we would have stopped that getting in there in the first place. And we talked about shift left and reducing the cost. This would have moved it well to the left and reduced a lot of remediation they had to do with their solution. So last one, CodeQL, by far the most complex part of advanced security, if you want to get into the weeds and write your own queries. But from a high level, it does have some simplicities that you can start using it straight away. So first of all, CodeQL is an analysis engine. And the best way to think about CodeQL is 3 steps. First of all, it prepares your code by creating a CodeQL database. Now, what we mean by database is your code, the DLLs, your jar files, even your JavaScript, that is the database. We're going to be executing queries against your code. And the queries come from libraries. So the originating company for advanced security is SEML, and they've spent quite a few years developing queries for different vulnerabilities across different languages. If you think about doing reflection if you're a .NET developer, you're doing reflection and you're looking over the different assemblies, trying to get properties and attributes out. CodeQL is very similar to that. You're writing queries that looks like an assembly statement, sorry, a reflection statement. And then the last part's interpreting the results. So when we run these queries over our database, which is our code, we'll generate a serif file, which is a standard file format for distributing security analysis outputs. So we get a serif file, it gets uploaded to GitHub, and then we see the output of that analysis. Supported languages, it's got a focus set: C++, C#, Go, Java, JavaScript, TypeScript, Python, and Ruby. Great thing about GitHub is everything is as code. So the way to manage your CodeQL queries is through GitHub Actions. Generates that serif file, uploads to GitHub. But also, if you've already invested in some security platform and tooling, so maybe check marks, and it outputs a serif file, you can then consume that serif file within GitHub. So we talk about that single pane of glass view of your repository security. You can bring it all back in and view the outputs of all of your security systems in one place within GitHub. So demo time again. Back to my repository. I didn't show my code, so it is a working application. So it's my Blazor application, and chuck some credit card details, all safe. This is the application that we'll be scanning. Get rid of that. We'll come across to security, oops, sorry, settings. So I've already enabled it for this repository. Ordinarily, when you click this button, GitHub is going to create a GitHub action for you that executes the CodeQL query. Now, because I've already done this before, there's another way to re-enable it for your repository, and we do that via actions. So I'm going to come into actions, and oh, I forgot to delete my one from yesterday. Cool. So I'll look at the one that I already put in there. We can see our CodeQL here. Oh no, sorry, that's just old runs, so I will have to add it again. All right, let's do a new workflow. I'm going to search for CodeQL. Configure. I'm just going to do this right now. It wants to. All right, we're just going to pop this to a new branch because it's not. Actually, so I'll try that again. What branch am I in? Let's go from new branch. Commit that file. I'll just get this kicked off because that's going to execute immediately, and then we'll go have a look at the code and see what that's doing. So that process created a new GitHub action in my new branch. And we'll run through this code and see what it's doing. So first of all, it's going to look at pull request to my main branch. Now, when I created that new action, created the branch, it also created a pull request as well. So that should be executing right now. It puts a cron job in there if you want to run these security checks periodically. So let's say there's new advisories coming out in the library of queries. That means that you can keep your, let's say you've got a code base that's legacy and we've got new vulnerabilities being defined. It means that we'll always get notifications for our old code of new vulnerabilities that have been discovered. And it breaks down into a few different steps. So first of all, we've got a strategy. It's picked up that my my application is C#, but we can add additional languages to that matrices, and it will run parallel executions across that strategy, across the different code bases. The first thing it does is initialize. We need to get all the CodeQL tools relative to our language into the hosted runner for us. So the initialize action is going to set up an environment for the languages that we've defined. It's pretty smart. It's going to try to auto build our code. But if we get any errors in this, we can delete this step and then just run a normal build function. And then the last part is the analyze. We're going to execute the queries against the database. So let's say we built some DLLs, and then they will be uploaded to GitHub for analysis. But depending on how fast I've talked, this will either be still running, which is, I think this usually takes 4 minutes. So what I'm hoping this will do is it will pick up an issue and put it into my PR for us to review. So let's have a quick look and see where we are. We can see here, analyze C#. If you had different languages here, you'd have analyze in brackets Java, brackets JavaScript. Okay, that is still executing. What I might do is look at one of my closed PRs, which might be a bit quicker. To finish executing to view the results. So while that's happening, I know where this exception is. So let's jump into the code and have a look at what it's going to find. What I'm expecting it to pick up is I have a controller here called data controllers, and I've done something a bit silly. I've taken values straight from the input. So my user is providing a value and an ID, and I'm going to run a SQL query, update person, set its name to the value where the ID is equal to the ID. Now this is a classic form of SQL injection. What my user could do is chuck some brackets in there, say delete table person or user, semicolon, and it's going to go run that query, delete my table if the identity for that connection has permissions to do that delete, or it could do something destructive. Like we already have update permissions, so we could truncate that table or delete staff from table, something malicious. Hey, look at that, we've finished. So now we can go and see if it has picked up. Okay, some checks are not successful. We see the CodeQL executed completely, but the code scanning, we've got an issue here. We've got one new alert, one high severity. So we're going to jump into the files. Now, because this wasn't introduced in this PR, I don't see anything here. I've just got the YAML for my GitHub action. But down the bottom here, we can see it's picked up on this and it's classified as SQL query built from user control sources and high. So I can remediate that within this branch, put it for review, and we've caught that issue. Now, if it was outside of this branch and it was in our main branch, we would see that come up as a code scanning alert. So we've got one alert here, but we're safe. We're not in our main branch, so nothing is actually out in the wild yet. So that's CodeQL. So it's going to give you great coverage for your team. You know, if you don't have, I think one of the big issues is that we don't always have the skills within our team to pick up on these issues. And back to the trenches, our poor client that was putting host keys into code. When we did that security review, we also found that pattern in their code. They were building up SQL commands and doing string interpolation to put values into their queries. So the advice for that client was to use SQL parameter or to use an ORM such as Dapper or EF code. But again, if they had GitHub Advanced Security in there, but we found it as our getting ready to go to production, So you saw that $7,500 figure. They had to go back and remediate that code, so there was time lost and dollars for their project manager. I know I'm getting close to the hour, so I'm going to start wrapping this up quickly. So security overview is the last thing I want to touch on, and it might be good just to jump across and show you this within the repository. Sorry, within the organization. So a lot of this, we've been dealing with the security issues within the repository, but if you're a product lead or you're managing security for your organization, you want a higher level to be able to view and respond to these security issues. So if we come across to, sorry, not insights, security. We've got this dashboard here where we can dive into all of these security issues. At a top level, we can see our risks, and we should see here, we've got secret scanning alert, which was Azure Active Directory client secret. We don't have any code scan alerts because we managed to capture that within the branch. It's not yet exposed on our main branch, the default branch, and we don't have any dependency vulnerabilities. But if we wanted to dive straight into what are my high repositories, we can filter it down here and we can zoom in straight on the issue and get in contact with that team to help them out. But also, we want to know which repositories are being reviewed. So I mentioned the licensing around advanced security and how it's based on the number of committers on your repositories. You might want to see which ones, I guess, first of all, you want to have dependency alerts across as many as possible, because you're going to keep up to date with your packages, keep supportability high, so we can have a look at what's not enabled. We can see our repositories there. Same with any of our other features. We can manage code scanning and we can manage secret scanning. If we're concerned about any number of issues, we can then dive in and get specific information. So here we see that alert that's come up for the Azure Active Directory app secret. And I've got another repository in here that is an example of all the worst things to do with applications. So we've got lots of critical issues here that we need to address. So if you're bringing an application into GitHub for the first time, maybe you're in TFS and you've got some web forms, bringing it in, or bringing 10 applications in, running CodeQL across the application portfolio, and then you can come in here and get this holistic view of everything that you need to address within your portfolio before you start app modernization efforts. So really powerful. Okay, and to wrap this up, look, these are all fantastic features, but at the end of the day, our developers do have some responsibility to be secure as well. And there's some additional features that we can use within GitHub to help drive that. The first of this is branch policies. With some of these demos, you would have seen that the alert didn't raise because we're in a branch. Within that branch, we're protected to some extent. And we want to keep our production default branch clean of issues. So we want to enforce branch policies, enforce pull requests to make sure that we get review on our work before we promote it up into production and deploy it into our cloud environments or even on-prem. Security policies. So there's a lot of documentation that you can have within a Git repository, like contributing your README file. Another one is your security policy. And what it does is it informs people that are contributing to your repository how they should respond if they do find a vulnerability. You don't want them going to the issues and opening up a new issue, because that now publicizes your security vulnerability to everybody that has access to your repository. And it's going to introduce a zero-day attack. So you might want them to contact somebody directly. You can create a private issue, deal with it until you get it resolved, and then publicly advise everybody once the threat has been removed. Secret management is really important. I talked about API keys. We don't want them in our code, but sometimes you need to have that key close to the repository. And GitHub provides secret management both at the organization level and at the repository level, and we can have a bit more control about those secrets by only letting them be used for specific environments. So using GitHub environments, we can say this secret can only be used for the development environment. And then we can couple that with approvals. So somebody needs to physically approve the deployment into that environment. And the last one is OIDC. So this is fairly new, both in AWS and Azure. You can create, well, for Azure, an app registration. And where we had that view earlier of client secrets, there's another tab there where we can enter in the details for our GitHub repository. So we've got federated identity there. GitHub will generate a JWT token, and then we can use that token to get an access token from our cloud platform. And if the app registration has the permissions, we can use it to do deployments. So now we remove the secrets from our repository altogether, which I've been wanting to have for ages. I hate having to create client IDs, client secrets, store them in the repo, manage them for different environments. Now we can use OIDC, which is far safer and removes the need for the secret in the first place. Look, Insight is growing in the New Zealand market. We're really strong in Australia. I just want to briefly touch on how Insight is working with GitHub and what's on offer in this region. So we are a verified partner, and we were one of the first verified partners in the APAC region. There's a lot of new exams for GitHub across administration, advanced security, and actions, and we've got a large contingent of consultants that have been certified across those, as well as migration efforts. So using the GitHub tooling for repository and pipeline migration from various platforms, including GitLab and Azure DevOps. We've got a few members as part of the GitHub Fast Track team. So this is a GitHub funded in 2-week engagement where we can provide some advice on your cloud DevOps strategy. We're a licensing partner, so we can, if you want to uplift existing Microsoft VS Pro or Enterprise licenses to GitHub, or let's say you don't have a presence there and you want net new GitHub licenses, we can assist there. And we're a service partner, so if GitHub is able to provide some services to you, we can subcontract under GitHub. And that's the presentation. Open for Q&A, and give my voice a little bit of a rest while you think of questions.
Oh, well, thanks, Paul. That was really interesting. And get some hands. And anyone want to put their hands up? Got questions?
No questions? Is anybody using advanced security? Actually, I see a hand over 26 people, so I don't know who.
It's Jeff. Jeff, do you want to come off mute?
Yeah. Hi, everyone. So my understanding of CodeQL is it's a, and I'm not strong in this area, so correct me, but it's like a static analysis tool in the sense that it's just going across the code base. Do you know if GitHub has any strategies around more of like a dynamic analysis?
Yeah, so no, usually you have those close to runtime, I think, or that's more your RAST. Yeah, I haven't seen anything on their roadmap. I think they're still trying to get visibility and adoption of these current tools. Yeah, I don't have visibility of it, sorry.
No, thanks.
Yep, Paul, I've got a question. Where does GitHub Pro fit into your table? Because some of us have got GitHub Pro subscriptions.
Oh, okay. It might be similar to GitHub Teams. Unfortunately, I'm not a licensing specialist, but I know you've got your personal account, you've got your team accounts, and then you've got the yearly enterprise licensing. So to leverage advanced security, my understanding is you need to be on enterprise. So if you're on Pro or Team, it's not going to be available to you, but I'd reach out to the GitHub licensing specialist or I can talk to our internal licensing specialist to try clarifying any of that.
Okay, thanks.
Johannes?
Yeah, hi everybody. Just a real quick question. So, I mean, this was quite focused on the enterprise level, but am I correct in thinking that most of it's actually available for the open source tier as well?
Sorry, the open source tier?
Yeah, like if you got public open source projects, you get many of the advanced security features made available to you?
Yeah, definitely. Almost all of them. So you'll get Dependabot, you'll get secret scanning. I have to go back to my table. There was one that wasn't available publicly. I think CodeQL, you can pull that in as well.
Pattern matching, I think, was not available.
Was really early in my deck. Yeah, security overview. So that dashboard.
Cool. Awesome.
And the only other difference was the secret scanning had limited. So if you're doing any custom patterns, that wouldn't be available to you. You're really limited to the GitHub partners that have shared their patterns. But there is quite an extensive list there.
Thank you for that.
Okay, were there any other questions or we just sign off? Okay, well, thanks very much, Paul, for your time. We really appreciate it. Thanks for everyone for attending. It's always good to see a good attendance, and speaking to Dan, hopefully in the near future, Microsoft will be opening up and we can actually do a kind of a hybrid event there. We were really good to see you all. We haven't seen each other for so long. So I'm really looking forward to that. But otherwise, thanks to everyone for attending, and enjoy the rest of the day.
Yeah.
Bye.
Thanks for having me.
Thanks, guys.
Cheers, Paul.
Yeah.
Bye.
Cheers.
Thank you.
Thanks, Will. You can stop the recording and we're done. All right. Cheers, everyone.
Cheers. Thanks, Paul.
Thanks.